Okay, so in this next example, we're going to find the image of a glide reflection. So what they are asking us is, does the glide reflection, so here's remember a glide reflection involves a reflection and a translation that runs parallel to the line of reflection. Does this glide reflection, where n is the line x equals 4, so that's our line of reflection right there, does it map triangle PQM? So PQM, let's go ahead and highlight that. Maybe I'll use blue. So PQM, this is the triangle that we're starting with. If we do these two transformations, our glide reflection, do we end up with triangle KJN? So let's do the two transformations and see if we think that's where we end up. So when we're doing the transformations, remember the composition, we start with the second one. So we're going to do the transformation where we move our x 0 units, but we move our y 4 units in the positive direction, which is going to be 4 units up. So each vertex is going to move 4 units up. So P is going to go 1, 2, 3, 4. And I'm just going to label that P prime. So maybe I'll use green. If we move P up 4 units, we land right here, P prime. We're going to do the same thing with Q. We're going to go up 1, 2, 3, 4. Again, this is telling us to do a vertical translation in the positive direction. So Q is going to land right here. I'll call it Q prime. And then M also has to move up 4 units. So here's M. We're going to go up 1, 2, 3, 4 and plot our point. This is where M prime is. I'll go ahead and draw in the triangle. So what's tricky about this example is we got some extra stuff we kind of have to filter through and ignore and not pay attention to. So right now, I think coloring it is helpful. I can visually see. All right, I started with the blue triangle. We had a composition, which was our glide reflection. We start with the second transformation. I moved my triangle up 4 units, and now it's the green one. So there's our first transformation. Our second transformation wants us to do a reflection across line N, and they told us that line N is x equals 4. So let's get that reflection line in there. Maybe I'll draw that in black so it's pretty clear. X equals 4, you go to the x-axis at 4. So I'm going to go over 1, 2, 3, 4, and I'm going to draw a vertical line right there. Here's the line x equals 4. That's our line of reflection. Now, if we take our green triangle and reflect it across this line, let's see where we end up. And we want to find out, do we end up at triangle KJN? So when we do that reflection, M prime is on my line of reflection. So when I reflect that, that has nowhere to go because it's on the line of reflection. So that's going to give me, I'll just label it M double prime. Then we have P prime. I'm going to connect it to my line of reflection. It's 1, 2 away. So if I reflect it across this line, it's going to go 1, 2 on the other side. So here's where P double prime is. And then we've got Q prime right here. We want to reflect that across our line of reflection. So count how far away it is, 1, 2, and go 2 in the opposite direction. I'm going to label it Q double prime. Let's connect our vertices. Here's our resulting image after the glide transformation, or the glide reflection, excuse me. So is the purple triangle, triangle KJN? So I kind of have been writing over this, but I can see here's K, here's J, here's N, and that's exactly where we ended up. So that would be a yes. It did map triangle PQM to triangle KJN. Okay, so we have just a couple theorems to quickly run through. This might be a little blurry on your packet, so feel free if you can't read something in your packet, look here. It might be a little bit more clear to write it in. So we have a theorem that says any rigid motion is either a translation, a reflection, a rotation, or a glide reflection. So we've got four rigid motions that we've learned about. So if transformation M is a rigid motion, if it's any of those, then all of these things are true. Then, well, all right, so our rigid motion could be a reflection across line L, or sorry, transformation M could be a reflection across line L, or maybe our transformation is a translation, or maybe the transformation is a rotation about our center of rotation P, or maybe the transformation is a glide reflection that involves a translation and a reflection. Adding on to that, any rigid motion can be expressed as a composition of reflections. So if your transformation is a rigid motion, so it could be any of these rigid motions, then the transformation could be equal to a reflection across line L, or the transformation could be a reflection across line L, or I guess a reflection across line M followed by a reflection across line L, or it could involve these three reflections. Basically, what we're saying is that rigid motions can be expressed as compositions of reflections as long as your transformation is a rigid motion.